Hello everyone. In this video, I am simply going to explain what exactly the way to find out a successor of a node in a threaded binary tree. So before explaining that thing, here I am trying to describe the overall structure of a node related to threaded binary tree. So if you will see the node, so what exactly the property that node will have, uh, it has 5 fields. So these are the 5 fields over there, and this is called L thread. This field is called L thread. This field is called L child. This field is called data field. This field is called R child, and this field is called R thread. So L thread, that means here I'm simply trying to write L thread, that's value will be either 0 or 1, its value. L child, it is going to either, it is going to point left child address. This R child field pointing right child address. And this R thread. So this is this R thread, its value is either 0 or 1. So, and mid one is the data field, that is holding the information or data, information or some value. So this is the uh, overall representation of a node and what exactly the work of all these fields. Using these fields, I'm here simply trying to create a threaded binary tree for a binary tree, and from there I'll try to get the way just to find out a in order successor of a node. So here this is the overall specification of the field. Using these specification, I am trying to create a threaded binary tree for a binary tree. So here I am taking, for an example, I am taking A, B, C, D and E. Before creating threaded binary tree, here I'll try to just find out the in order sequence of this tree. So if you will traverse this thing in order, what exactly the result will be there. So the sequence will be in order traversal sequence of this tree, in order traversal sequence will be like a B, D, and then A, then E, then C. So that is over, because this E is in the left side, so that will be over there. So that is the sequence. If I'll create the threaded binary tree, so in that case your root node, that will be like a header, so that will go in the left side and the right side as well of the B and H. That's I'll go to explain right now. So just first of all, I am trying to draw an equivalent threaded binary tree of this tree. So in that case, as I told, this field A will have the 5 field. So A is over here, and then I'll take B. So this B will take, this is like a 1 2 3 4, so that is B, and this C is also like a, in this way, 1 2 3 4, so this is C, and then D, so this D will be over here, and this E is in the left hand side. So I'll try to create that thing. and the data I'm putting over here in the form of node, what I explained just before this picture. So that is five fields for each and every node, and I'm trying to connect this thing. This L child will point this address, R child will point this address. This is in the right, so this will go to point there, and this E is in the left side of the C, so this is as in this way. Now the things are that what exactly, and if your child, if you have the actual child, so in that case this L thread value will be 1. So here this is the actual child, so this L thread is 1, this L thread is also 1. Here this is the actual child, so 1. This one is the actual child, so 1. Here no other D and E do not have any child, so in that case both the value will be 0 0. These two value will also 0. Here no right child of C, so it is also 0. Here no left child, so it is also 0. Now the things, if we will try to make a thread over here, so as I have discussed in the previous lecture, if your L thread value is 0, so in that case for that node you have to check the predecessor and just point to that specific predecessor. So in that case, if I see for the D, so what exactly just behind B, so here I'm trying to create a thread by the some other ink into other ink, so that you could, so that is a thread. So D just it is 0, so L child will go to point a predecessor, so this one is the predecessor over there. In the right side, what exactly, D is A, so here it will go to point A using dotted line. Here solid line is representing child and the dotted line is representing thread. Once again for E, this is 0, so L child will go to point predecessor, and what exactly the predecessor of E, that is A, so that is over here, and the successor of E is C, so this will go to point this location. In case of C, there is no success because the R thread is 0, so you are looking for the successor, there is no successor, so put it in the dangle. This we will try to find out where exactly it will go to point. And in the similar way, D, this L thread is 0, so this L child will also go to point to the predecessor of B, but here there is no predecessor, so in that case it will also in the dangle. And now the things are here for this tree, each and every fields except this B and C have either child or thread, and that is properly connected over there. But in case of this left child of B and the right child of C, that field is still dangling, both pointers are dangling, so in that case I'll create another node that is also of the same field, 5 fields, and that is called header. And now this field, this node will work as root of a threaded of the threaded tree. So it will be root. So what exactly the things? First of all, this both the dangling pointers will point this root node. So that's over here and that's over here. So means the left child of B and the right child of C will have the address of this header or the root node, because I told already written this will work as a root, so you can also write as a root. Now the things are here, whether this A will be in the left side or right side of this root. So exactly for the threaded binary tree, it will go to the left side. So it is like this. So that is the child. That's why I have made this thing by the solid line. It's not a dotted. Wherever the dotted line is there, that is thread. If solid line is there, that means it is a child. Although it is of the different color, but still it is a child. Clear? And everywhere where there is a solid line, that is a child. So A will be the child, left child of this your root, and the right child will go to this R child will go to point itself as a right child. And this thing, because this is the child, left child is here your root node, so it is child, so once again it is 1, and this side also it is pointing itself as a child, so it is 1. So this is the overall equivalent structure of this tree as a threaded binary tree. Here you can see each and every field of each node is either pointing some data or it has some value over there. So you can see it is completely filled. So now it is a threaded binary tree. What exactly I'll do using, now I'll erase this tree, and from this threaded binary tree I'll try to find out and implement the pseudocode just to get the successor of a node in this threaded binary tree. So what exactly the things will be there? Here I have to find out the successor, and here I'm also assuming uh, or there is the prerequisite to understand a pseudocode is the C language. Here for this node, if I try to create a structure, C structure, so before creating the C structure, I have to define what exactly the fields are over there. So in that case, the fields of a node, any one of the node, it will have data, what exactly that is. First part, it will have data. Another thing is there that will have L child, and it is like a pointer. Then R child, that is also a pointer, and then L thread, its value will be 0, its value either 0 or 1, that will be the value, and 1. Then R thread, so that value will have the 0 and 1. I'm removing this thing because that is, here I'm looking just for to understand the overall fields required for your node, so that is end node. So that is the required fields for any one of the node. For that thing, I'm trying to write a C structure for this node. So in that case, and I am assuming here you people know the C language a little bit. And if you do not have, just go and learn little bit C language to understand exactly the code and the traversal and the flowing of the code, just to find out the the successor of any one of the node. So here I'm creating a structure, that is a struct for this node field. I'm trying to create a structure over here. So a struct, I'm writing here also the term I'm using, struct node. So for this struct node, but exactly their data, here I have taken the data as a character, so I'm taking as a character char. So that will be data, that is character type. Here, depending on the what exactly the information is over there, if it is an integer, you will write integer and something, or the in a normal uniform way. For the uniformity, you can write data type data, so that as type whatever the type of data you want to store over there in a node in the data field, you can do that thing. So character data here for this tree I'm making. Then L thread, so that is also like a, I'm taking here as an integer type. You can take also the boolean form. Here I'm taking as a int L thread, because it will have only the integer value, either 0 or 1. Same int R thread. Now exactly the problem, this L child and R child, these two are pointers, and the pointer of type of node itself. So just to define that thing, you will write struct node. Now it is the data type, and in the normal way, what exactly you are using just to declare a pointer, in that way it is there L child, and then also for the right child also struct node R child, and that is the overall structure. So this is the structure definition, C structure definition of this node fields. Clear? So this is overall there. Now I have given the name struct node, that is the data type. So repeatedly, I do not want to write a struct node over every time. So for that thing, I am using the type def, renaming that thing. Type def struct node, and I'm giving here the name node. So this is like a node. So now this node, only this node can be used as a data type directly. And from using this node as a data type, I'll try to create a function which will be used, and I'll also write code inside the function, or define the function. I'll try to write the body of the function so that we can find out a successor of any one of the node of this threaded binary tree. So this is the overall structure, and I'm reviewing this thing, and I'll try to write a function. So this structure is over there. uh, Now I can also wipe out of this thing, and I'll try to, now our focus is only to understand this node and using this node. So if I'll try to get the successor of any node, so I'm writing the function over here, in order successor. I'm using only in order just to understand. Yeah, I'm looking for the in order successor of a node in a threaded binary tree. So as a parameter, what exactly I'll pass? I'll definitely pass any one of the node, and that node will be of the type of this node, and that's why it is node, and it is the linked list representation. So in that case, any one of the value you are going to, so I'm here giving the pointer, means this pointer will go to point n, will go to point any one of the node over there. So that is of the pointer type, and whatever the result will be there, that is a successor of that node, any one of the node. So that is also, this function will go to return. So that is also a type of node. So there is a requirement of pointer which will give to point that node which this function will go to return. So in that case, what exactly will happen? So this is the overall your prototype of the things of your function. This is the name of your function. This one is, you can say, as a name of the function. This is the return type of your function. Return type of function. This one is the parameter of the function. Clear? Here I have written fn, so that means in a short, this actual meaning is function. Clear? So in order suck, that is the name of the function. This is the parent node. Star n, that means as a pointer I'm giving as a parameter, and the return type is also of the pointer that is going to point some specific node of a tree. So that is there, and now I'm trying to define this function just to get the in order successor. Here the things are that in a threaded binary tree, always we will follow the in order, either for the predecessor or successor. There are the two more ways are also there just to traverse the tree, that is the pre-order and the post-order traversal. But here we will focus only on the in order, because threaded binary tree has been defined only for the in order. So that's why it is written over there, in order successor. So in that case, if I look, I'm looking for the in order successor. So if we will go for the in order, so in that case, what exactly the things? Successor. So for any one of the node, as we know, for the in order, what exactly the sequence is? L, V, R. So L is left subtree, V is that root or the node, whatever you are looking for, and this is right subtree. That will be there. So in that case, that is the left subtree. So what exactly the things? I look for the successor. Then what exactly will the successor for this V, that a specific node, that will be right. So I'll try to go first in the right side, and for defining the function, first thing is required, that is the curly braces. So here I am trying to define. I'll take, so I'll go for the right hand side. So what exactly the things are there? I have to take some pointer that will go to take that value node star p, that's I'm taking, and this will go to take the value, because for this vertex I'll go to the right hand side. So right will be definitely, that is the right subtree, so the right child. So that will any one of the nodes. Suppose for n I am taking, so n dot right child, so r child, that will be, means right hand side, the child address of this specific n node will be assigned to a pointer of p. Clear? And after that I'll check whether it is a thread or a child, actual child. So for that thing, what exactly the requirement is, I'll check over here. If n dot r, so because right hand side I'll go now, r thread is equal to 1. If it is there, that means actual child is there. So if actual child exists, then only I'll traverse. If actual child does not exist, so in that case I'll return the value of the node, whatever is going to be pointed by p. So in that case, I'm simply trying to check whether this n child right thread is r thread value is 1 or not. If 1, then in that case only I'll traverse. In which way I'll try to traverse? Because in that case, for the successor, once I'll go to the right, and then I'll try to come back in the left side till I'm not reaching at the null children or null child, or you can say the value of 0. So what exactly I'll do, I'll go for while inside if, that is not out of, so I'll write in this way. After this condition is satisfied, while, here I have to check whether L child exists or not. So if p dot L child is equal to 1, so n dot r thread is equal to 1. If it is 1, then I'll execute while loop with the condition while p L child equal to 1 till the condition satisfies. For that thing, that time what exactly I'll do, p will go to point, what exactly it will go to point, p dot L child, and that will go continuously till I am not getting p dot L child is equal to 0. That means it is not going to point any thread. Till that time, I'll traverse left, left, left. That will be there. And when that condition will be not satisfied, so this loop will terminate. And after that, whatever the node is being pointed by this p, that will be returned. So that is return p, and that is the overall predecessor of this specific node n. You can check that thing. I'm trying to uh, run this code for this specific threaded binary. So check the things here. I'm taking node in order successor node n. For example, suppose I'm taking the node like a. Here I'm taking a. So in that case, what will happen? So in case of a, so at the place of n, there will be a. So here I am here declaring another pointer p that will, so first of all, if I am taking here a, so this will go to point, n will go to point this location, and now I have to check what exactly the p is going to point. So p will point what exactly, nr child. So nr child is pointing over here this location, so p will point over here. N is pointing this location, p is pointing that location. Now I'll check, after pointing this location, I'll check whether n dot r thread, that means this one, n dot r thread, is it equal to 1? If it is there 1, so in that case, now I'll check whether p L child is equal to 1. P L child, this value is 1. Sorry, it is written in a different way. So it should be written like a p L, not L child. It is the p dot L thread. P dot L thread is equal to 1. I'll check the things p dot L thread is equal to 1. So here I'll check after this thing n r thread is equal to 1. That is there. That is equal to 1. So then I'll check whether p L thread is equal to 1 or not. L thread here 1. So if it is 1, then what exactly I'll do? P will go to point p L child. So p L child, this is pointing over here, this location. So now p will come from here to this location. So p will start to point this node. Clear? And after this thing, once again it will check, because that is in the loop. So this will be, this statement will execute till this condition is satisfying. So once again it will check whether p L thread is 1. It is not 1. So in that case, this loop terminates, and then what exactly the things, this, your if will also terminate over here. The if part is also terminated. And after this if, so in this way we will write, so this if curly braces, this is for this one, this if is for this, and then for this I'll write return p, and then curly braces, this curly braces is closing curly braces for this one. So here what exactly the things, after reaching over there, PL thread it is 0. So in that case, this condition will not execute. This condition is not satisfied. So this statement will not execute, and this will come out from this loop, and then it will also come out from the if body, and then it will return P. So what exactly the P is over here? That is the node. What exactly node is it pointing? It is pointing E. So what exactly the successor of A? So the successor of A. So the successor of A is E. You can check that thing in a in order traversal, or in the sequence it is already written over there, or the tree, whatever the actual binary tree was there. There's the successor was also for the A, it was E. So in that way you can get the successor of, for any one of the node. If you want, you can check this one. Also, if I'll try for the getting for like a C, in case of C, what exactly will be? Just check for the C. I think it will be little interesting. So if it is C, so here I'll take the thing. I'm removing the first value of N and P, and then I'll try to get the things for again for C. So what exactly the successor of C is over there? So in that case, here I am putting the value of N will be C. Here I am taking as if I'll call this thing for the function call will I'll do and put the this address C. So in that case, what will happen? So it will go node P, another pointer I am taking, that will go to the n dot r child. So n dot r child, what exactly will be there? Here this C is over here. So that is, this one will be like your, this is your n, and it will look for the R child. So what exactly in the R child is pointing to H. So this will be the position of P. Clear? So this is your position of P. So this is your position of P, and after that thing, I'll check whether NR thread is equal to 1. So N, this is R thread, its value is 0. So the value is 0, so in that case, it will not go to execute any part of either if or while. So this entire statement will be skipped, and it will return P. So return P, what exactly P is going, P is pointing, here P is pointing H, or the root node. So that's why the successor of C will be this H. If I'll point it is as a H, header node as a H, header node as H. So the successor of C is H. In this way, for any one of the node, you can get the successor in a threaded binary tree. So that's all for this video. That's all for this video. Thank you for watching it. Kindly subscribe and like the channel to get latest videos and updates. Few more channels are also there in the last to get latest updates in new dimensions and domains. Kindly subscribe and like them as well.